Hello, and welcome to the Scientific Adventures of Beardman. Today we're going to take a look at permanent magnets and the magnetic field that they create. I'm going to step you through an activity that will help you to create the magnetic field yourself using a couple of bar magnets, and all you really need is one compass. I've got 4 here. I may use all of them, I may not. All right, before we get started here, go ahead and touch your magnets together. If they are strongly attracted to each other, then you're in good shape. Don't worry about it. But if they aren't very strongly attracted, you can't pick one up with the other one, then go ahead and see if your teacher has a magnetizer. In my classroom, here's where you would find it, and here's how you'd use it. First of all, if you're in my class, you'll come to this cabinet, and you'll find in here a magnetizer. Okay, take it carefully, please be careful. You can grab the bin of magnets. You'll find some bar magnets. Take those 2 bar magnets, because you'll need 2 yourself. On the magnetizer, you'll see that there's a little indication where you put the north end down and the south end down into these little holes here. So go ahead and do that. North end down, south end down. Then just take another magnet and lay it across. There was a bar that came with it, but we don't have that, and so we put a bar there. And then you just put that down there. That's going to generate an enormous electromagnetic field. That electromagnetic field will pull all of the domains to line up, and it's going to strengthen the magnet. Okay, so now you've got 2 nice, very strong magnets. And of course, make sure everything's put away nicely once you've gotten your materials. So the first thing you'll need is a piece of paper, and you'll need to take it and fold it in half, just like that. Try and get it as close as you can to accurate, because we're going to draw 4 pictures, 4 magnetic fields, and we'll do one here, and one here, and one here. Okay, so go ahead and once you're done, go ahead and set your piece of paper back down. We're going to take one of our bar magnets, and we are going to set it directly in the middle of that piece of paper, and we are going to outline it. So we know, once we remove the bar magnet, we'll know where it had been when we drew the magnetic field. And the last thing we'll do is you'll notice that there's a north and a south marked on here. We're going to go ahead and label those north and south. So once again, once we remove the magnet, we'll be able to remember where it was. Then, first of all, magnetic field, what that means is it's our way that humans developed, however many years ago, to determine how one magnet will affect another magnet if another magnet were to be put in that location. Okay? And we define it as the direction that the north pole of a magnet would point. Okay, so if I take a magnet, first of all, when you get your compass, take your magnet, move it away, and you need to see which side of it is pointing towards the north. Especially with these cheap magnets that I've got, they sometimes flip. So when you buy them, they're intended that the red painted side points north. And I happen to know here in my house, that direction is north. And since the red is pointing that direction, that means it's north. Now, some students get a little confused because you can rotate this, and the north you can see points any direction. That is just there so that if you know what direction north is, you can line the N up with north, and then you can see where west, east, and south are. So the red spot there points towards the north. This is because the Earth has a magnetic field, and the Earth's magnetic field points north. So the north pole of this magnet is drawn towards the north. That's why they named it that way. Somebody found out this rotates, this side points north, so they called it the North Pole. So now if we bring it near here, if we want to know what the magnetic field is around this magnet, we can just put this anywhere. And look, it's no longer pointing north, which is this way. It's pointing with the direction that the magnetic field is pointing around this magnet. If I want to track how that's happening all over here, I'm just going to right underneath this, ideally right in the center here, I'm going to draw a little arrow that's pointing the same direction that the needle of the compass is pointing. That needle of a compass is a tiny magnet. And then I just move it somewhere else and draw another little arrow. And your goal is going to be to get somewhere around 30 arrows drawn here. All right, I'm going to speed this up and get the rest of my arrows drawn. Actually, I'm going to stop there. It's your turn. Go ahead and pause the video and draw out 50 or so arrows on your space here. Fill it up in between all these little spaces so you begin to get a sense of what the magnetic field looks like. Now it's time to ask you a question here. So, which of these 4 options looked like the magnetic field that you drew? Does the magnetic field around a bar magnet look something like this? We'll call that A. Like this, B. Like this, C. And like this one, D. Go ahead and mark your answer now if you're doing the play pause it, or however your teacher decides that you should do it, or if you're just watching this for your own edification, then go ahead and take your pick. The next drawing you're going to do is going to use both bar magnets. On this next one, you're going to set them on the sides like this. Again, trace out where the magnets are, lift them up, and write your letter in there. South for south, north for north. And now take your compass and once again, go ahead and pause the video while you're drawing your arrows. All right, now that you've drawn your arrows, take a look at the picture here and decide which one looks like the direction the arrows were pointing in your magnetic field that you drew. And go ahead and select A, B, C, or D now. All right, now for our 4th drawing, go ahead and take it and put both the south ends of the magnets on the paper. Okay, and again, outline them and begin putting your compass on the paper and marking what direction the magnetic field is pointing. Don't forget to mark your paper so you remember that this is the south-south. And when your teacher collects the paper, they are able to see the south-south. Okay, again, you just set down your compass and draw the arrow the direction that the north pole of that is pointing. All right, now take a look at your 4 options again, A, B, C, and D, and mark which one matched what you saw when you had 2 south poles on your paper. All right, now finally onto our last one. We're going to put our magnets down, and you probably already guessed what we're doing last. You're going to mark the paper and have the 2 north poles of the magnets sticking onto it. Oops, got to mark that. And then you will use your compass to draw the arrows around on it. Okay, setting it down and again, lifting it up and drawing the arrow right underneath it. Go ahead and do that now. All right, go ahead and compare your drawing to these 3 pictures here, A, B, C, and D, and go ahead and mark the one that matches your drawing most closely. Go ahead and mark that now. All right, and so that's it. You've done it. Go ahead and take, in my class, go ahead and take your paper that has all your drawings on it and go ahead and turn it in on the front desk and make sure your name and period are on it. And if you're not in my class, or if you are, I hope you have a great day, enjoying living in the Earth's magnetic field. And we'll catch you the next time on the scientific adventures of Beardman.